Hi, welcome to day 2 of the Plumbers Summit. Kicking us off today are Joel and Luke giving us an update on Preview 3 and I assume async and stuff like that.
Oh, yeah.
So very exciting. Please welcome our first speakers of the day.
Hello. Right. Is mic working? Sounds like it. All right. Joel, you ready?
Yeah, can you hear me?
Yes, I can. Perfect. All right. So this is just a Preview 3 update, kind of continuation on the presentation that was in the last Plumbers Summit. A lot of progress to talk about since then. So the agenda is I'm going to give just a one-slide TLDR of kind of the goals, of this Preview 3 release. Our current status, what's remaining before a Preview 3 that we're like pretty sure, yeah, we need to do this stuff. Then there's a collection of things that are like, yeah, if we have time, we should do this, but it doesn't, it could slip, it could be in a 0.3 point something release. Uh-oh. Okay. So there's that second box of possibly before Preview 3, but maybe after.
Actually, can you reshare?
Oh my God. Oh my God.
Apologies, a little bit of video issues on our end.
I think it updated on me. It was asking me, can I update? And I was like, no, don't do it. And it's like, I'm gonna update you anyways. Oh my God. So this. Oh, shit, not that one. Jeez. Oh my God, it does this, the Mac thing. All right. Mm-hmm. Go away. All right. So back?
You're back.
All right. We're now on the latest version of Zoom, or Teams. So there's a second bucket of possibly before Preview 3 stuff, but maybe after. And then there's the things that are probably definitely after Preview 3, but like make sense as follow-ups because they belong as part of the overall, async story. So we're gonna kind of go through these in sequence. So I'll start with the TLDR. By now that we have Preview 2 out, there's some felt problems that we'd like to address that a lot of folks here have definitely had and found issues and filed bugs about. So we want to fix those. And the first one's around developer experience. The automatic bindings generation you get from anything using WASI.io, like around pullables, is hard to use, and it kind of tends to require the manual glue code that we're generally trying to avoid anyways. We'd like those bindings to be usable without somebody having to write glue code. It's very hard, not impossible, but very hard to virtualize WASI.io. If you virtualize one interface that uses WASI.io, you end up being forced to virtualize all of them because you make your own function that returns a pullable. So you have to virtualize pullable, and now the pullable is used by every other interface that uses pullable, so it just is very ineffective. It's very hard to compose two components that do async stuff. People have tried, and it's just hard to put the stuff together, if not impossible. And lastly, these WASI.io interfaces, when you kind of like dig into the call sequence you have to make, it's kind of chatty and probably suboptimal if you really like measured it aggressively. And this is not a surprise. This is, we knew this well before shipping preview 2. This is just an intentional, choice to ship and iterate, because waiting another 1 to 2 years to fix the stuff before releasing preview 2 would have been terrible, and we probably wouldn't all be here. So, this was just a known kind of milestone thing that we wanted to do. So preview 3 adds native async to the component model to fix these issues, and in a way that binds to built-in language features like async await and streams, or go routines and channels, or green threads. It's modularly virtualizable, so I can, for example, virtualize just WASI file system and not have to think or touch WASI HP if my single component ports them both. And then we do that by we can remove WASI-IO entirely. So you don't have to mess with this single shared pullable type. Instead, you just use a stream feature in your respective interfaces. And the component model kind of just implements them natively. And it's composable, in that I can have the same interface that is both import and export. So I can chain, HB proxies together, just, using component linking. And we do so by avoiding this what color is your function problem. Wait, can I make this thing go away? Yeah. Hey, even better. Making whether or not you're implementing a function or consuming a function an implementation choice. The function signature doesn't have to say async. It's just a thing you'd say when you're lifting or lowering. And we want to have an efficient ABI. And the phrase shared memory is said a lot, and it means a lot of different things to a lot of people. But one thing a lot of people mean when they say shared memory is I'd like to pass out a pointer to my memory, and then asynchronously I want the OS to be able to read or write from this memory. And we do that. So is it shared memory in the sense of like my memory's public and anyone can touch any of my bits? No. But it does allow this very important use case that people think, usually say, I want shared memory. This is actually what a lot of use cases for shared memory want is I'm passing you a pointer out so the host can now read or write from this from like the kernel. And without having to go through some intermediate guest process memory before it goes into WASM's linear memory. So that's the TLDR. Let's talk about where we are like today. And so first I'll do this in 3 pieces with Joel. Design, spec, and then prototype implementations. So design-wise, the good news is that the design I presented last time at the Plumbers Summit, and then also in a WASI-IO presentation, is basically unchanged. So if you got to know what that was saying, like it's not entirely different, or not very much different at all. And the little tweaks I'll highlight later. We have a WASI-HP 0.3 draft. And it shows this unified WASI-HP handler interface. And the key part of it, the punchline is this resource body. It has a constructor that takes a stream of bytes and a consume method that returns a stream of bytes. And it uses a future of trailers. And this single resource type can be used by the single request and response types used in the single WASI-HP handler type. So we don't need to have incoming and outgoing variations of all these things that ultimately cause all the things not to compose. So we just have this. We can write this, and it means what you want it to mean, and it's very concurrent. And importantly, also, this is not a breaking change in the way that preview 1 to 2 was a breaking change and a huge amount of pain for everyone involved. In particular, the component model async stuff is additive in the binary format. We're not breaking existing component binaries. We're just adding new type and can in built-in opcodes in the same way that we extend core WASM by just adding new things that used to not validate, now they do. So it's additive at the component model level. But of course, WASI-HP 0.3 is incompatible 0.2. Because of we're just changing the interface to be look like the thing above, but this is fine because it's versioned and it's in the name. So a host can simply support both 0.2 and 0.3 for as long as it wants until nobody cares about 0.2, and so it's fine to have multiple incompatible versions because they're just it's just versioned interfaces. The only thing that's hard that you really need to avoid breaking is the component model binary format, and we haven't changed that or broken that. So so it's not really a breaking change. It doesn't, so therefore it can be a lot more smooth to do than preview 1 to 2. Spec-wise, currently in the component model repo, there's the definition of this async option on lifting and lowering. And importantly, all the combinations of putting async in all the places compose. So yeah, of course, there's this whole discussion and presentation about how synchronous style components can compose with asynchronous style components and the right thing happens. But additionally, inside of a single components, you can have synchronous exports that make asynchronous calls, because that is a thing you want if you're have a main function and you want to do async like libuv stuff. And the opposite, if you're an async function, you can make synchronous calls, because that's the thing sometimes you need to do when you're in an async language, but you're in a context where you're not actually async and you're like, I just need to do a log right now, or just do this synchronous destructor, or synchronous drop right now. So all the options compose, and they do what we think is the right non-surprising thing. This is fully written out in the Python canonical ABI codes, and there's tests of that code. It's in the canonical ABI MD, which provides this sort of explanation of why the Python code does what it does and how to understand it, and then summarized at a high level in this async.md, all this in the component model repo now. And the built-ins, just as a summary of what are added alongside this async option, there's a task return, so that while I'm running, I can return my value and then keep running, because I need to return a value and then finish up what I'm doing. That's just a fundamental use case that comes up a lot when you're doing async functions. There is a task.backpressure, and this is a tweak from the earlier thing. Before there was a task.start, and you could delay starting, so that was a way to express backpressure. But we realized that wasn't sufficient. We need to be able to trigger backpressure at any point in time during the handling of a task. So now there's just a task.backpressure that just flips a bit. Do I accept new incoming requests? Do I accept new incoming export calls? And when you flip it, they'll queue on the other side, and you don't have to worry about it. So you don't get oomed. If you're starting to run out of memory, you can just flip on backpressure, and then you don't get any more async export calls. And there's task.wait, pull, and yield. Wait's like kind of an epoll thing. It waits on all of your subtasks, which are tracked. So it's like you don't have to pass in a big list of ON things. You just wait for any of your subtasks to make progress. Then you find out which one. Pull is a non-blocking version of that. It says, is anyone ready right now? And then yield is sort of like saying, I'd like to let somebody else run, but I don't want to actually wait on any IO. So if anyone's ready, it's a cooperative interleaving. And a subtask.drop. This is a tweak from the earlier thing before. When you got the event that a subtask, a call that you had made was done, you would get an event and you would immediately drop it. Subtask.drop lets you wait and explicitly drop it, which in various racing conditions will be very important. So that was also a small tweak. Yeah, so those are the built-ins. There's also this use task return option for synchronous exports. And this is kind of what we realized is once we had this task.return that lets you return your value and then keep running, we're like, oh, this is a better post return. Right now we have this thing called post return. The idea is you return your value, and if you need to do some cleanup later to free the memory, you have to have this post return function, which can free it and do other wrap up stuff. But it's kind of annoying and it's kind of weird because you have to it's just special. Whereas with task.return, you can do it anywhere in your control flow stack, just return your values and then just keep going. So it's task.return is just what we should have done in the first place. So instead of breaking anything, we're saying, okay, there's this option. So you can say, even though I'm synchronous, I would like to use task.return instead of the whole post return stuff. And then maybe later we can deprecate the post return if we determine there's actually no good reason to have it. So yeah, there's that too. So that's what's already in the component model repo. The next thing that's being worked on, this add stream branch, is this new stream type. So the canonical ABI Python code and tests of it are fully done. So I'm pretty darn happy. It's spelled out in excruciating detail in the Python code. So have the design, and so the next step is just to write it up, write prose to describe it in the canonical ABI.md and async.md. And the built-ins added by stream. There's a stream.new. And a small tweak from the presentation earlier, instead of getting two ends, a readable and writable end, you just get the writable ends. And then when you lift it, it creates the readable end on the other side. And so that has various benefits. There's a stream.read and write. These are the workhorses. You say this is the readable or writable stream that I would like to read from. Here's a pointer to my memory. Here's here's how big the buffer is. You don't have to fill up all of it. When you write any of this, tell me about the progress. And it's callable, these individual built-ins are callable both synchronously and asynchronously. So if you call it synchronously, this is the ability to just do a blocking read, just like a traditional libc read. But there's the asynchronous variant, which says, tell me if you finish right now, but if not, tell me that you're not done, and then I'll wait on it later. Then if there's a stop read and stop write, which is to say if I've started a read, and there's no progress, but I need the buffer back. I don't want to delete the whole stream. I don't want to close everything. I just want my buffer back. So I can say, please stop. Give me back my buffer, even if there's nothing ready, even if it's empty. And then lastly, when you're totally done with the reader or writer end, you can just drop it. And that tells the other side the stream is closed. So those are the built-ins, and they'll be, the PR will have a lot more details to review. So I'm not going to go into depth about them, but it's just kind of a summary. So that's the status on the spec. And now I'll hand off to Joel to talk about some implementation progress.
Thank you, Luke. So if you were at the last summit, I think in January, you may have seen the little demo I did of this thing called ISIS WASFA. Stands for I sync, you sync, we all sync for async. And that was just kind of an experimental prototype or proof of concept that deliberately tried to avoid making pervasive toolchain changes, that would be required, of course, to actually implement the ABI, which was very much a vague concept anyway at that point. But still, at the same time, provide a working preview of what the guest application developers experience would be once we do have proper composable concurrency. And so it was a cool demo. It served its purpose. It's somewhat obsolete now, as I hope I'll convince you here. You can take a look at it if you haven't seen it, but it wasn't really meant for a long-term use. What is in fact the first draft of what I would propose as the real implementation is, I have a link here to a prototype of async, which consists of temporary forks of WASM tools, WIT-bindgen, and Wasmtime, implementing the actual ABI, or at least a snapshot of the ABI as it existed around April earlier this year. I actually had to take a break from working on this in May to focus on .NET and a few other things, so I'm just now coming back to it. But where I left it off, all the major features from a guest perspective are implemented. You've got async exports and imports. You've got task.wait, which Luke just mentioned. Futures and streams. Futures are just essentially degenerate streams that you can just send one thing to and you're done, and receive one thing from. And then errors, which eventually we're going to have things like stack traces and payloads and whatnot. Right now it's a very super minimal implementation of errors. And then all the basically the whole matrix of kind of function colors, so to speak, are satisfied. So you can do async you can import async, an async export, you can import synchronous and async export, and so on. Basically, all the combinations are supported, which did mean a bit of refactoring in Wasmtime to essentially generalize the fiber support that we were already using to provide concurrency from the host perspective. Now, essentially, we're making that available from the guest perspective as well. And you can think of this as sort of a poor man's version of stack switching, where you can't actually create a new stack from within the guest, but you can be called potentially on multiple stacks concurrently from the host. And hopefully that can lay the foundation for real stack switching later on. And then along those lines, I haven't actually tested the callbackless async exports. That is something that's going to be crucial for languages like Go. This is where we need guest toolchains to catch up, or someone like myself needs to write some handwritten WIT or WAT code that is guaranteed reentrant. And this has to do with the guest has to be aware of being reentrant here, because it needs to be able to potentially have multiple shadow stacks in play at any given time and switch between them and so on. So that's the status of that prototype. Feature-wise, we also have guest and host bindings generators. I've modified WIT-bindgen both for the guest and the host, at least for Rust. And then we have some demo apps that kind of show off the composable concurrency benefits of WASI 0.3. In terms of next steps, there's a lot of stuff left to do. The main thing is, again, the ABI that's currently implemented is essentially an April snapshot of where we were at. A few things have changed, minor things, not necessarily even visible to an application programmer, but important to address. And some of the stream and future ABI I just made up because we didn't have anything written down yet. So as Luke fleshes that out in the spec repo, I will reconcile the implementation. And another thing is, of course, the big thing, right? I'm in the midst of rebasing from a six-month-old snapshots of these various repos onto the current main branches, and with an eye to adding some smoke tests and getting those things PR'd under feature flags. So it's part of the upstream code bases, and people can start then really playing with it rather than just checking out my forks, and then we can work from there. And then the next step after that, big one, would be adding actual WASIP3 support to Wasmtime WASI and Wasmtime WASI HTTP. And I didn't list them because I was running out of room on this slide, but other things that we will need to do is, expand the guest support beyond Rust, obviously, things like Python, JavaScript, .NET, Go, and other things, essentially update, say, WASI file system to, as well. We don't even have WIP files yet for the 0.3 versions of those things. So we'll want to get cracking on that. And oh yeah, I see a question in there. Pavel asks, is sync to async possible to implement in Jco in the browser? I believe the breakout session yesterday covered this a little bit. I know there's this promise integration, JavaScript promise integration support that's coming down the pike, and stack switching as well. As I think the browsers have finally kind of agreed upon what that's going to look like. So I'll leave that question authoritatively for someone like Till and or Guy to answer, and I think we've got a presentation coming up from them. But I think that's essentially where we're headed. And I think that's all I got for status.
Great. Thanks for that, Joel. And just also amazing, incredible work on all this so far. And thank you for all of that. Yeah. So that's kind of where we are now and kind of what's coming up. So let's talk about what are the features not yet kind of in the spec that probably we want before preview 3. So one is this future type, which, as Joel said, they're just kind of degenerate streams, so this should be pretty easy to add. The next one is this error type, and there's a component model issue kind of describing the design space instead of options, the problem solved. Yeah, but we can probably start with something with pretty minimal functionality, none of the fancy anyhow features, really just some debug string you can get on the other side. It's probably sufficient. A non-blocking function attribute, which is very easy to add. It just says this function promises not to block. If it tries, it'll trap. We don't statically ensure it. It just sets a clear contract. And what that means is for bindings generators, since it can't block, don't even bother with any of the async machinery or bindings, just make a normal function call. And this is totally appropriate for getters and setters or things you're no, there's no reason for this thing to block. Next is to specify how async works in Stark functions. Mostly they should work kind of in the obvious way. It's familiar with JavaScript and top level awaits, kind of like that. But the interesting kind of cool thing is because an async function can return and then keep running, the fun idea is maybe a start function is considered finished and initialization and instantiation continues once the async task returns. But then if it keeps running, you could say this is background tasks. And this has been historically kind of a challenge when we talk about structure concurrency. I mean, it's mostly what you want. It gives you the async call stacks. It's really nice, but people are what about background tasks? And you're well, what if your start function just keeping running after it said it's done and finished initializing is your background task, and you can shunt work to that thing to run in the background. And now there's a clear way to explain it. If we were to visualize it in async call tree, it would be attributed to oh, this one's background task. You could call it that. And so maybe this is a thing to discuss and say, well, how does it actually look? And can toolchains generate this? But there's a fun idea there that's worth thinking about. And one way or the other, having some sort of answer, because can you use async start functions in Start? Probably you want to, because you want to call some async imports. And so yeah, so that's an interesting detail to figure out. Also, how cross-task dependencies work. This is a more advanced case that probably will just show up, when I just have multiple async exports running concurrently, and then one waits on the other one's, future or promise. How does that work? And so this is a detail we talked about with Aaron Turon way back in the day, and there's probably another little additional built-in necessary to allow waiting between tasks. And next, maybe at the moment, if you attempt to wait and you don't have any subtasks, there's nothing to wait on, so it just traps. Like, there's nothing to wait on. Why are you waiting? You're going to deadlock. You've definitely deadlocked. But instead, maybe we can say this is more like an async tail call. What you're saying, oh no, actually I got that wrong. That's a different thing. That's what wait finish is. If you try to say your task is done and you have subtasks and you would orphan them, then it traps. It says, no, you have to wait for all your subtasks to finish. But maybe what we want to say is, oh, it's more like an async tail call. What we're saying is, when they're done, I'm done. So like, don't keep me alive just to say I'm done when they're done. I'm gonna tell you that right now. And so this can allow the instance to be torn down. So the practical way this shows up is you have a handler, it gets a bunch of streams, it wires them up, takes some input streams, puts some output streams, and like, it's wired up all the streams, and now there's no actual work left to do. It's just let the host finish streaming all the streams. And so you want to be able to tear down the WASM instance, which is an important optimization in some high performance multi-tenancy HTTP proxy contexts. Yeah, so those are additional things probably important for Preview 3. Implementation-wise, as Joel was talking about, we want to have a Wasmtime implementation, as Joel was also mentioning, and they asked in the chat, J-code transpile. It seems like we'll have the primitives to be able to solve this using JavaScript promise integration to achieve the stack switch. If we don't have JavaScript promise integration, which is on a really good track, by the way, I think it's like fully implementing Chrome, maybe in an origin trial, and Firefox is actively working on it and polishing some of its last things before it's shippable. But if things take long, and I don't know what the story is for Fire, but I think they've started, or JSC, I think they've started. Anyways, Binarian's Asyncify can be a workable polyfill for JavaScript promise integration. It just has some overhead. So I think we can get those two as implementations. And then on the producer side, we already have active work in Rust, JavaScript, Python, .NET, and Go, and they all have a really cool async story or concurrency story that we want to integrate with. And this, getting all these languages working enough to say like, yeah, I think this works for this language will be a really good validation that actually we've achieved cross-language, concurrency, composable concurrency. So currently we're wanting to add integration for each of these languages initially. And of course others are welcome, but these ones are ones that we're all seem to be focusing on. Yeah. And not all WASI interfaces need to really change, but this WASI one is like the one that's really top of mind to take advantage of all this stuff. And so this is probably the only one we really want to focus on, refactoring to use all this stuff, but anything else, maybe too, but definitely this one. So given that's the definitely probably, let's talk about the possibly, but maybe not. So on the component model level, async resource drops and destructors. In a lot of contexts, like your C++ destructor, Rust drop, you really want to just synchronously drop, and you want that to be synchronous. But it makes sense that it can be asynchronous. The spec stuff has worked out how it would work. It's just a matter of implementing it and figure out language bindings. There's a lot of contexts where it's not a problem to have async drop, like in a finalizer. So there's a lot of places we could use it, and languages ultimately can choose to synchronously drop or asynchronously drop. It's just a choice you have. Cancellation, another very important aspect. It's often an integral part of how the whole system works. We've definitely thought about how in general it works, but it's not fully spec'd. And there's also a question of like how precisely to integrate it with the language bindings. And so this is a thing where there's plenty of stories of designs changing as they add integration or like regretting certain design choices. So we really want to figure out how it should work and even maybe have it spec, but maybe not implemented in time for Preview 3. But it's definitely a thing we're going to focus on to make sure we have a pretty good story before we declare anything done. Also, as Joel mentioned, there's a lot of richer things we could add to errors that look like kind of like a Rust anyhow error. The ability to stick payloads in that you can pull out based on a dynamic type test. Stack traces and the ability to take an error and then extend it with more context to produce a new error that you can then propagate. So you can have more of a story of how your error flowed through the system. Another good idea that goes way back to work with Dan on things and streams is this concept of a lull, which is really just saying nothing is coming for a while. And if you find all the places where streams have been specified, you can find issues where people hit the lack of this ability. Sometimes it's called flush. Flush is a very confusing term because people think it means like write it all to disk, and it's like definitely persistent. That's why flush is maybe a bad term because it has like a lot of mixed connotations. But a signal that says nothing is coming for a while, clear out your buffers, send them to any of your output streams, and propagate this down the chain is a valuable signal, and when you don't have it, you just get various, performance problems. And I linked to one particular issue of like server-side streaming React people asking for this in what wig streams, and everyone's like, yeah, that seems valuable, but it's, it's a subtle thing. It actually shows up very simply in the canonical ABI. At the moment in the spec, it just says, when you do a read, you only find out when you've made some progress or the stream is closed. So you can assert that, either it's closed or I got some bytes. But we can just say, or you can get 0 bytes and it's not closed, and that's this lull. It's like, hey, nothing's coming for a while, so I'm going to tell you got nothing, but you're not closed. So like, that can just be the signal. And then the question is, the more interesting question is like, how does this actually show up in bindings generation? Does it just show up as I got nothing but you're not closed, or do we try to have a call? What does it bind to? Like, there's interesting bindings questions there, which is I think worth working on. And lastly, we've talked a lot about how can we get rid of or do less cabby realloc. And one of the cool ideas is maybe we can remove cabby realloc entirely. And there's this whole written out idea called the lazy, a tweak to the ABI that allows you to lazily lower values. And I won't go into it. I'll just link to that issue. And it's not specific to streams, but I think streams would really benefit from it. But this doesn't block streams in any way, but it would be really complementary to them. On the WASI level, I think the big thing that would be really valuable, but I don't think necessarily blocks preview 3, is refactoring CLI main, or now it's called run, but call it main because that's what it is, to take full advantage of streams as parameters and results. In particular, the reason I think this helps explain what the change we want is right now main gets its arguments from imports. And what you would want is for arguments to be arguments to the exported main function. So for example, if I have some JQ command and I want to import it from JavaScript with ESM integration, I want to just be able to call it and pass my parameters as parameters, and multiple times. And right now this would be really hard if your standard in is an import, but it could be really easy if we just make stream a parameter of main. So that would be really nice, but I don't think it blocks preview 3. It'd just be nice to have at some point in time before we're done. Maybe I'll pause here and say, is any questions? And the last thing is definitely after preview 3 for what it's worth, but maybe I'll stop here and see if anyone has any thoughts or questions.
Right. So there's more stuff in WASI that we want to refactor as well, right? Like,
oh yeah,
go through electric buckets and all that stuff, right?
Yeah, that's right.
I'll maybe add one of the potential complications with the params and results stuff that we were talking about yesterday is like if you're composing things in a single core module and you're linking together like multiple language runtimes, and they all sort of want to have their own. I guess maybe this is less for stood in and stood out, but for like env args and stuff like that. If those are passed as arguments, then you have to like manually plumb them through to everyone, versus like if they just have an import that's like, give me that, everyone can kind of just do it on their own.
And that might be why envars belong as staying as an import, or WASI can be, and whereas standard in and standard out is a parameter. But yeah, I think it is challenging from a bindings goop because there's just a lot of ambient assumptions that main is special in the way standard in, standard out, argv work is special. And that's why we didn't do it in the first place, because we talked about this and we're like, oh my gosh, this is gonna be hard. So at some point in time we should do this, but it's gonna be a refactoring lift for various, historical reasons. I can keep going. And so, yeah, these are follow-ups that, maybe a preview 4, maybe post 1.0, who knows? So first of all, there's some obvious optimizations. One is a really old one, Bailey filed years ago, which is given a data segment, I want to get a stream from it. And this will allow me to pull in data that I statically embed in my component as a data segment, but pull it in asynchronously. That would be really cool. Still a good idea. And then you integrate into a big distributed runtime. You can lazily fetch that data segment over the wire only when I start streaming it, only if I start streaming it. Really good for lazy static asset distribution. This is like a pretty awesome point to get to, but maybe not blocking. But if somebody really needs it, they can join and help push this forward. It's actually pretty simple. It's just like a little cannon built in, takes a data set. Well, yeah, anyways, there's a little few things to worry about, but it's totally doable. Pipelining multiple stream read and write calls. At the moment, when I do a read, I can't do another read until I get back a result of this read completed with these results. But it's totally in the semantics easy to relax that restriction and say I can have multiple reads, maybe up to a fixed amounts, and then I can start finding, it's like I have a pipeline of reads and then I find out about them asynchronously. And it's a thing you can do in like various other asynchronous systems, but you know, it does open some design questions like how many, probably not an unbounded amount, a fixed amount, a configurable amount, a statically configurable amount. So we're gonna wait until somebody actually like kind of wants this optimization, and then we'll like dig into the details. And there's bindings questions of how this looks, because a lot of streaming async interfaces, like the source level, like JavaScript streams or Rust streams, don't allow you to do this. I don't think so. So there's bindings questions also. But it would be a totally doable optimization, and then what you're saying is, here's a buffer. As soon as you, the kernel, finish writing into this one, here's the next one. So you can just roll right on. You don't have to go to guest code to find out and just get the new buffer. It's already queued up. And like you see this in graphics with like output streams of frames. You have like swap chains. You know, it's a pretty common pattern in various high performance streaming situations, and we could totally do that. Chaining multiple async calls together, sometimes called promise pipelining. If I call one async function, get back a promise for it, I can just pass it as the parameters for another async call, and I don't have to bounce back and forth between me and that other call. I can just say when that one's finished, it just kicks off the next one. But there's some interesting questions about how to make that work. And probably it can connect with lazy lowering and in a cool way. But anyways. And the really big exciting one is thread integration. So, you know, multi-threading, definitely a big concern, thing we want. So, you know, we have now this shared everything threads proposal being worked on in the core WebAssembly CG, defining ultimately a shared type on core WASM functions, and then ultimately figuring out what's the TLS, the thread local storage story that we bake into LVM and all the places. And that's an interesting discussion. It's gonna take a while for that proposal, I think, to make progress. But that is, I think, what we depend on. But the important thing is, once we have async, I should be able to do any of only concurrency, where I'm just using async, only parallelism, where I'm doing totally synchronous functions, but internally I'm making threads and using all sorts of shared memory stuff to just make that synchronous function run faster, or use both together, where I have asynchronous functions that are internally using threads to make the asynchronous functions run faster and take advantage of all the kinds of parallelism available to me. So they threads should compose with async, and I think it's important that that we design them so that they work together. They're not like two like mechanisms. Do you want to use threads or do you want to use async? You're like, no, just do as much work as you want. It's harder to do threads, so maybe start synchronous, and if you want to be asynchronous, do that. And then if you want even more parallelism, do some threads, and that's like a nice like do more work to get more win. The exciting idea, and this is only a thing that came out from working async, is can we have shared not be on the type so that it's a color that propagates and infects everything like async? We didn't want to have, you know, what color is your function for async. Maybe we don't have to do it for shared either. Maybe we can, you know, avoid it in the same way, and we just say like, if I lower async and you lift async, hey, that call happens totally on whatever thread it started on, and that just works. But if I lower async, that means I can call your function on any thread, and if you lifted not, I said if I lower shared, I can call it on any thread. If you lift not shared, well, we already have a back pressure mechanism. We already have the ability to like async coordinate between different tasks, so we could make that just work. And if we're, you know, so all the combinations can work out here. And then the cool thing is we don't have to like have shared versions of all of our WASI interfaces. We don't have to make this function color thing and, oh, this is a shared thing. This isn't. No, we can have the same thing. We can make it just an internal implementation detail in a way that I think composes, but I'm not sure. But I've pitched this idea to a few people who would naturally be skeptical, and they're like, yeah, maybe I think that might work. So anyways, that's a fun thing to figure out later. After shared everything is a thing. And that's the end.
Thank you, Luke. Do you have time for questions? We have time, but would you like to accept questions?
I would like to, but let me figure out.
And thanks, Joel, too. Sorry. I see one here over Taylor. Give me a second to unmute the room. All right, Taylor.
My question is actually just generally like, is there anything us as WASM community members can do to help make sure this gets across the line? Like, do you need any help? What can we do? Like those kind of, that kind of thing. I just want to make sure we know what we can do to help, because I feel like this is pretty important to get across the line, as you said.
Great question. Maybe we'll let Joel take a first crack at it.
Yeah, at this point, I'm trying to think. I haven't really thought deeply since I haven't really had any particular offers to help with the stuff that's currently in progress, and there are advantages to just it only being me and not having to explain where we're at and like what, you know, break stuff up into smaller chunks that could be parallelized. So I think until I can kind of get to the stage where this stuff is upstreamed into the various repositories, I kind of feel like I just want to keep working on it on my own. But I think after that point, you know, there's going to be a lot of stuff that it opens up, you know, basically all the different languages, you know, bindings generators for all the different languages, creating idiomatic bindings for async, you know, imports and exports. That's super parallelizable. Starting to, you know, work on a new design, you know, an updated design that embraces streams and futures and whatnot in WASI sockets and WASI file systems. That's super parallelizable. That could start happening today, actually. And then in terms of implementing those updated interfaces, that's also something I think the implementation might need to wait until we actually get the component model level stuff upstreamed. But yeah, so I think my goal, honestly, is you know, in the next month and a half ahead of WasmCon, is to get this stuff merged as much as possible, and I think that's going to unlock a lot of you know, parallelism from an implementation standpoint, and we'll have a lot of stuff people can work on.
Alex.
One thing I might also add to that I think would be helpful is I think we'll want to sort of develop a set of guidelines of what it's going to look like to actually release P3 eventually. So this is sort of like, how exactly do these proposals land at an unstable state? How exactly does it look like to have these things gated, or how exactly does it look like to start using the binding generators in a gated, unstable fashion? And so I think outlining that plan, I mean, and this is only going to be possible to discover as Joel moves along in the implementation and as we move along in the spec and things like that. But as these things become more clear, I think it'll be very useful for the WASICG to talk about how is this development going to look like. I think it's going to be useful for Wasmtime to talk about this is how it's going to be gated, this is how you get access to it. But I think I'm sort of just reaffirming a lot of what Joel was just saying. Just once these things are landed upstream, it's going to be a lot easier to say this is how you turn it on, and that's how you can start playing and iterating and helping fix bugs, things like that.
Thanks. I was just asking because I figured that was not to put stress on you, Joel, to say like parallelize the work you're doing. It was more like making sure we all knew what we could do to help when we got to that point.
Before we get to you, Liam, we do have a question in chat, which was, could main just take a resource that exposes args and inst.io? That was from Lan.
I mean, yeah, maybe there's some interesting resource time questions. I guess the question is moving things that feel like arguments from imports into arguments, and then the details of how precisely lessons. Yeah, up for design.
The challenge there is still this problem of making sure it gets plumbed into the right places. Like you have to somehow have to be hooked into main. If you're a language runtime, you have to somehow hook into main to get access to those environment variables, which is the tricky part here.
Yeah, that's
right. Liam?
First, I just want to really compliment you and Joel for all the meetings before the meetings that the two of you have across the ecosystem. I know that there's been a huge amount of alignment to get to this point, to get everybody in this room, agreed and pointed in the right direction. And my question is maybe to Joel. You mentioned WasmCon coming up. Would it be appropriate, or do we want to see if we can get on the schedule there some sort of an announcement or a call to action, or a talk or something like that? It is a slightly different persona. It's more of the downstream user personas that we have there, and less I'm going to troll some people in the room, less the WASM developer persona. The people here that are building WASM. Is there anything that we would want to try to launch there or get public facing or announce?
I will be doing a talk at WasmCon on this topic, so I'll certainly announce whatever there is to announce as part of that talk. I don't know that at this point I want to promise anything beyond that talk and whatever that talk contains, which is subject to how much work I can get done in the next month and a half. But as we get closer, if I can hit a milestone, if I can get everything merged in, maybe we could make more of a splash. But yeah, I do want to make sure I'm not over-promising and under-delivering is the only concern I would have there.
Okay, we've got 3 simultaneous tracks, but we still have a couple of like keynote style things open. So station for a topic.
Chris, you have your hands up online.
Thank you, folks. I caught the tail end of the presentation. This is awesome. I'm really excited by it. On the threading stuff, we have a bunch of environments where we have multiple host threads trying to talk to multiple WebAssembly threads and trying to coordinate all of that. I know it's early days. It's a bit of an open question, but is that something you guys are thinking about too? Or are you just thinking about threading inside the engine, or is it inside and outside the engine and how they all talk to each other? Any thoughts on it yet?
Yeah, that's a great question. And I think, yes, we're thinking about that thing. The idea was that kind of got at the end is if we say you can lift shared, what you're saying is, here's an export. It can be called on any host thread. The host can show up on a thread and just call from that thread because the WASM on the other side says, I'm ready for it. I'm going to do the complex stuff with having multiple stacks and worrying about thread level storage and all that stuff. So by lifting shared, you get a core WASM API that exports a shared function that says, yeah, I'm ready to be called from any thread. So that, yes, that's not just internal thread, definitely internal threading, but but also this externally invoked threading is a thing I think we can and should support.
Awesome. Awesome. That sounds pretty cool. Thank you, Luke.
Yeah.
Does the toolchain know which imports it should lower as shared?
Shared is this is so far I would just be guessing it, but I would think if you're a highly multi-threaded sort of language and maybe you have the hyphen shared specified on your build command as C does.
So basically all the things.
Everything shared,
Sure, this is going to be formulated perfectly, but in Windows, for example, there's a restriction on accessing the window handle to the thread that created the window handle.
Mm-hmm.
So if you've got multiple components and they all want to do multiple UI components and they all want access to the same thread, when they're made perhaps multi-threaded themselves, is there any provision for like being able to identify a?
Yeah, that's an excellent question. It also shows up in the browser too, which is DOM. The DOM is also main thread only. It's a challenge that the browser folks are working on right now. It's kind of neat that same constraint shows up, I think, in a lot of places, especially when UI is involved. And the way it is expressed at the core WASM level is like, I don't get a shared function for any functions that are implemented that are main thread only. And so I can't call them on any random thread. If we allow this lower shared from any that can be called on any thread, what that means is if I call on not the main thread, I'll get back pressure. And then I'll get an asynchronous handle that will queue up the call that, already we have all this mechanism for here are my arguments. I'm waiting for you to copy them out. Tell me when you're done copying them. That's already a thing in async. So we're like, oh, well, maybe that just tells the host to do the right synchronization to make that call from the right thread, from the right event loop. And this is speculative. It sounds almost too good to be true. So I'm not sure what the problem is yet. So that's why. But the cool, unique ingredient we got the shared nothing thing. We got, this async mechanism that's native, and that's kind of a new ingredient. So maybe that's why we can do better at this than previous.
Any other questions for Luke or Joel, either in person or online? All right, thank you very much. Just give us a couple minutes now to get ready for our next speakers. Thanks.